Okay, in this section 8-6, we're talking about really two concepts, the dot product and then finding the angle, using the dot product to find the angle between two vectors. All right, so here's the definition of dot product. So if you've got two vectors, then to find the dot product, then you multiply the horizontal components and then add them with the product of the vertical components. All right, so the dot product is just a single number. Kind of like magnitude of a vector is a single number, the dot product is also a single number. All right, here's some properties of the dot product. Doesn't matter which order you do them in, you can switch them, they're still the same. The dot product of the zero vector and another vector is always zero. Here, if I add two vectors together and then take that resultant and do it with the dot product of another vector, that would be the same as the dot product of that other vector with the original vectors and then add them together. And then of course the dot product is actually equal to the magnitude squared, okay, which is kind of interesting. Let's see. And of course it makes sense because this is actually, the square root of this is the magnitude, and so if you square the magnitude, then that'd be your dot product. Then of course here, if you take the dot product of two vectors and then multiply that by a scalar, that is the same as taking the scalar of one of the vectors and then doing the dot product, which is also equal to the scalar of the other vector and then times the dot product. Okay, so interestingly enough, and kind of following the same multiplication rules, it's not distributive, right? There's not two separate terms, so to speak, here, so you don't multiply the c by both of them, just one or the other. All right, so first thing is some practice at doing dot products. And so let's see if we can find the dot product of these two vectors. So what do I need to do? I need to do 4 times 2, which is 8. And I need to add that with 5 times 3, which is 15. And then so that means my dot product for these two vectors is 23. All right, same thing here. That's 2 plus negative 2, which I'm just going to go ahead and write as 2 minus 2. So the dot product of these two is the 0 vector. The dot product of these two is the 0 vector. All right, dot product here, 0 times 4, 0, minus 6, negative 6 is the dot product here. Okay. So now that we've had some practice at doing the dot product, we're going to utilize the dot product now to find the angle between two vectors. The angle between two vectors. Okay, the angle between two vectors. Right? So the angle between two non-zero vectors can be found using this equation. The cosine of the angle is equal to the dot product of the two vectors divided by the product of the magnitudes of the two vectors. So that is how we can actually go through and find the angle between two vectors using this formula. Let's try it. And so I want to find the angle between these two vectors. The angle between these two vectors. Now if you kind of wanted to draw it out, right, then you could to kind of get a perspective as to, you know, whether is it more than 90, less than 90, whatever the case may be, just to make sure you're kind of in the right ballpark. Sometimes that could be helpful if you're not sure of your work. But let's see if we can do this. So it's going to be cosine of the angle is equal to, all right, the dot product of the two, which is going to be on the top of the fraction 12 plus 15. 4 times 3, 12. 3 times 5, 15. Over. All right. Now it's going to be over the magnitude of the first one, which is going to be the square root of 4 squared plus 3 squared times the magnitude of the other one, which is the square root of 3 squared plus 5 squared. All right. So now we need to kind of simplify this side a little bit. 12 plus 15, 27. On the bottom of my fraction here, this is 16 plus 9, 25. So that's square root of 25 times. That's going to be 9 plus 25, square root of 34. Again, just kind of continuing to simplify here now. We will have 27 over square root of 25 is 5, so that's 5 square roots of 34, because that doesn't simplify anymore. And so what we've got now is we've got the cosine of the angle is equal to 27 over 5 square roots of 34. And since I'm just looking for the angle and not really simplifying this as an answer, I'm not going to bother rationalizing the denominator here. I'm not going to bother getting this square root out of the denominator because this is not my final answer. I don't need to put it in a simplified form. All I need to do is just use this value to get the angle. So right here from this, without having to take that extra step, I'm just going to take inverse cosine of both sides, and let's get the angle. So that's going to be the inverse cosine of 27 over 5 square roots of 34. And let's let the calculator finish that out for us. We're in degrees still, so we'll want to double check and make sure that we are still in degrees. Okay, and we are. Remember, it defaults to radians every time you restart that app, so just make sure you double check that. So we're going inverse cosine of 27 over 5 square roots of 34, and that is 22.17. So the angle between these two vectors would be 22.17 degrees. Okay, and of course that's provided that these two are coming from the same initial point. They've got a common initial point. Okay, in order to be able to have an angle between them, obviously. All right. Let's try one more of these. So now I want to find the angle between these two, right? So again, following the formula, cosine of the angle is going to be equal to the dot product, right? So 2 times negative 4, that's 6 times negative 4 is negative 24. And then plus 3 times 2 is 6, so negative 4 plus 6 on the top. On the bottom, I need the product of the magnitude. So the magnitude of the first vector would be the square root of 6 squared plus 2 squared times the magnitude of the other vector, which is the square root of negative 4 squared plus 3 squared. All right. And we can keep this going to negative 18 on the top of the fraction. And that's 36 plus 4, that's square root of 40, times square root of, so that'd be 16 plus 9, 25 there. All right. So keep that going to negative 18 over square root of 25. We can go ahead and call that 5. And let's see. Square root of 40 can be 10 times 4, but square root of 4 is 2, so we'll go ahead and take that out and leave the square root of 10 underneath. All right. And so from there, I see 2 dividing into 18 9 times, so we'll just call that negative 9 over 5 square roots of 10. Okay. Now we can go back to finding the angle that we simplified that down a little bit. And actually, you don't even really have to simplify this down. If you want to type all this whole string into the calculator and take the inverse cosine of that all in one step, that would actually work, as long as you make sure you're careful to type everything in correctly. But it always is good practice to simplify things down, as you're going to be doing that throughout your whole math career in school. All right. Let me see here. So we want the cosine of the angle is equal to negative 9 over 5 squared roots of 10. So I need the inverse cosine to both sides, so that means this angle is going to be equal to the inverse cosine of negative 9 over 5 square roots of 10, and that is going to tell me what my angle is going to be equal to between the two vectors. So now we can go here, and I just need to change the top on this one to a negative 9, and I need to change the square root underneath here from 34 to 10, and then my angle between the two is 124.7 degrees. All right, so there you go.